Question number 51. For x square not equal to n pi plus 1 and n belong to natural number, then we have to find the integration of this. Let's see the solution of this question. So here we put the value of x square minus 1 equal to t. So put x square minus 1 equal to t, differentiating both sides with respect to x, then we will get this is 2x dx equal to dt. This implies that x dx equal to dt by 2. So in the place of x square minus 1 we put the value t, and x dx we able to put dt by 2. Therefore above integration we able to write as integration of root over 2 sin t minus sin 2t divided by 2 sin t plus sin 2t dt by 2. So we know that sin 2t we able to write as sin 2t, which is equal to 2 sin t cos t. After that we able to write as integration of root over 2 sin t minus 2 sin t cos t divided by 2 sin t plus 2 sin t cos t dt by 2. Now we take 2 sin t common from numerator as well as from denominator. Then we will get integration of root over 2 sin t we take common, then we will get 1 minus cos t divided by 2 sin t 1 plus cos t dt by 2. After that 2 sin t and 2 sin t cancel, and in that place we able to use half angle formula, that is cos 2x we able to write as 1 minus 2 sin square x. Now 2 sin square x we able to write 1 minus cos 2x. When we apply the half angle formula, then this is 2 sin square x by 2, which is equal to 1 minus cos x. So in the place of 1 minus cos x we able to put this, that is 2 sin square x by 2. Similarly 2 cos square x by 2 we able to write 1 plus cos x, and this 2 we able to write here, which is equal to now 1 by 2 integration of root over 2 sin square t by 2 divided by 2 cos square t by 2 dt. After that this 2 and that 2 cancel again, then we able to write this as 1 by 2 integration of root over 10 square t by 2 dt, which is equal to now 1 by 2 integration of 10 t by 2 dt. So we know that integration of tan x dx we able to write as log of sec x plus c. So above integration we able to write as 1 by 2 log sec of t by 2 divided by 1 by 2 plus c. So this 1 by 2 and 1 by 2 cancel, then we will get log of sec t by 2 plus c. So we know that our t, which is equal to x square minus 1. So in the place of t we will put x square minus 1. Therefore this is equal to log of sec, in the place of t we put x square minus 1 divided by 2 plus c. So this is our answer. Option number A is our correct option. Question number 52. We have to find the integration of this. Let's see the solution of this question. So here, to solve this integration, we have to divide the numerator and denominator by cos to power tan x, which we also able to write cos to power 5x whole square. Therefore divide numerator and denominator by cos to power tan x. Then the above integration we are able to write as integration of sin square x cos square x divided by cos to power tan x divided by sin to power 5x plus cos cube x sin square x plus cos square x sin cube x plus cos to power 5x whole square divided by cos to power 5x whole square dx. After that we cancel cos square x with denominator, then we will get cos to power 8x in denominator. So which is equal to integration of, we will get the numerator as sin square x divided by cos square x and 1 by cos to power 6x upon sin to power 5x divided by cos to power 5x plus cos cube x sin square x divided by cos to power 5x plus cos square x sin cube x divided by cos to power 5x plus cos to power 5x divided by cos to power 5x to power whole square dx. After that we will get sin square x upon cos square x, that is tan square x, and 1 by cos to power 6x, which is equal to sec to power 6x, and in denominator this term we will get tan to power 5x. and we cancel cos cube x with cos to power 5x, then we will get cos square x in denominator. After that, sin square x upon cos square x, which is tan square x. Similarly, we cancel cos square x with this, and this term we will get tan to power cube x, and this is 1. So in denominator we will get tan to power 5x plus tan square x plus tan cube x plus 1, and in numerator we will get tan square x and sec to power 6x. Above integration we able to write as integration of tan square x sec to power 6x divided by tan to power 5x plus tan square x plus tan cube x plus 1 whole square dx. Now from these two terms we will take tan square x common, and this we able to write as sec to power 4x into sec square x, which is equal to sec square x whole square into sec square x. So therefore this we able to convert in this way. Integration of tan square x sec square whole square sec square x divided by, we will take tan square x common from first two term, then we will get tan cube x plus 1, and from last two term we will take common 1, then we will get tan cube x plus 1 whole square dx. Now we are able to write sec square x as tan square x plus 1, and the denominator we are able to write as tan square x plus 1 tan cube x plus 1 whole square. If you distribute square, then we will get tan square x plus 1 whole square tan cube x plus 1 whole square. So our denominator, which we are able to write in this way, then we are able to write as integration of tan square x, this is tan square x plus 1 whole square, this is sec square x, divided by, we are able to write this as tan square x plus 1 whole square tan cube x plus 1 whole square dx. Then we cancel this two term, then which is equal to integration of tan square x sec square x divided by tan cube x plus 1 whole square dx. Now we put tan x equal to t, then we will get sec square x dx equal to dt. So in the place of tan square x we write t square, in the place of tan cube x we write t cube, and in the place of sec square x dx we write dt. So the above integration we convert in this way: t square divided by t cube plus 1 whole square dt. Now again we put t cube plus 1 equal to u. If you differentiate both the side with respect to t, then we will get t square dt, which is equal to du by 3. Now in the place of t cube plus 1 we will write u, and t square dt we will write du by 3. Then this integration we convert in this way: integration of 1 by u square du by 3. So this we able to solve in this way: 1 by 3 integration of u to power minus 2 du, which is equal to 1 by 3 u to power minus 2 plus 1 divided by minus 2 plus 1 plus c, which is equal to 1 by 3 u to power minus 1 divided by minus 1 plus c, which we able to write in this way: 1 by 3 minus 1 by u plus c. So this we able to write as 1 by 3 minus 1 by u plus c. So in the place of u we able to write 10 cube plus 1, which is equal to minus 1 divided by 3. In the place of u we write 10 cube plus 1 plus c. Now again in the place of t we able to write as 10x. Then this is equal to minus 1 divided by 3 10 cube x plus 1 plus c. So this is our answer. Option number D is our correct option. Question number 53. Integration of sec square x divided by sec x plus 10x to power 9 by 2 dx is equal to, let's see the solution of this question. So here we take sec x plus 10x, which is equal to t. Put sec x plus 10x, which is equal to t, and we take this be equation number 1. If you differentiate this both the side with respect to x, then we will get sec x 10x plus sec square x equal to dt by dx. Now we will take sec x common from these two terms, then we will get sec x, this is 10x plus sec x dx equal to dt. Now this is equal to t, which we will take from this. Then this we able to write as sec x into t dx dt. This implies that sec x dx, which is equal to dt by t. Now in the place of sec x dx we able to write dt by t. So it is given in numerator sec square x, which we able to write sec x into sec x. One of the sec x with dx we able to write dt by t. For another sec x which we convert in term of t, for this we take the help of equation number 1. So equation number 1 implies that. So equation number 1 we able to write as 1 by sec x plus tan x equal to 1 by t. After that, we rationalize left hand side, then we will get 1 divided by sec x plus tan x into sec x minus tan x divided by sec x minus tan x, which is equal to 1 by t. So denominator we able to write sec square x minus tan square x, which is exactly like the formula a square minus b square, which is equal to a plus b, a minus b. So this implies that we will get sec x minus tan x divided by sec square x minus tan square x, which is equal to 1 by t. So we know that sec square x minus tan square x, which is equal to 1. Then this we are able to write as sec x minus tan x, which is equal to 1 by t. So we take this be equation number 2. Now adding equation 1 and 2, then we will get sec x plus tan x plus sec x minus tan x, which is equal to t plus 1 by t. So tan x and tan x cancel, we will get 2 sec x, which is equal to t plus 1 by t. Therefore sec x we are able to write as 1 by 2, this is t plus 1 by t. Therefore this integration we are able to write as integration of, in the place of sec square x we will write sec x into sec x divided by sec x plus tan x to power 9 by 2 whole dx. So in the place of sec x plus tan x we are able to write t. Similarly, in the place of sec x dx we are able to write dt by t, and in the place of sec x we are able to write 1 by 2 t plus 1 by t, then which is equal to integration of 1 by 2 t plus 1 by t divided by t to power 9 by 2 dt by t. Now t to power 9 by 2 into t we are able to write t to power 11 by 2. So which is equal to 1 by 2, which is taken out, integration of t divided by t to power 11 by 2 plus 1 by t divided by t to power 11 by 2 dt. So if you solve this, that is t into t to power minus 11 by 2, which is equal to t to power minus 9 by 2, which is equal to 1 by t to power 9 by 2. And again if you solve this, then you will get 1 by t into 1 by t to power 11 by 2, which is equal to 1 by t to power 13 by 2. Now this is equal to 1 by 2 integration of this, we will get 1 by t to power 9 by 2 plus 1 by t to power 13 by 2 dt. If you integrate this, that is integration of 1 by t to power 9 by 2 dt, which is equal to integration of t to power minus 9 by 2 dt, which we able to write t to power minus 9 by 2 plus 1 divided by minus 9 by 2 plus 1 plus c, which is equal to minus 2 by 7 t to power minus 7 by 2 plus c. If we integrate this, then we will get minus 2 by 11 t to power minus 11 by 2 plus c. Then this we able to write as 1 by 2 minus 2 by 7 t to power minus 7 by 2 minus 2 by 11 t to power minus 11 by 2 plus c. Now we will take minus 2 common from both the term and we convert this to 1 by t to power 7 by 2. Similarly, this 1 by t to power 11 by 2. Then this is equal to 1 by 2 minus 2 we take common, and this is 1 divided by 7 t to power 7 by 2 plus 1 divided by 11 t to power 11 by 2 plus c. Now 2 and 2 cancel and we will take t to power 11 by 2 common from both the term, then which is equal to minus 1 by t to power 11 by 2, and this is t to power 11 by 2 divided by 7 t to power 7 by 2 plus 1 by 11 plus c. If you solve this, then you will get t to power 11 by 2 into t to power minus 7 by 2, which is equal to t to power 11 minus 7 by 2, which is equal to t to power 4 by 2 equal to t square. So in the place of t, we able to write this, that is sec x plus 10x. Therefore this we able to write as minus 1 divided by sec x plus 10x to power 11 by 2, and we know that this equal to t square. Sec x plus 10x whole square divided by 7 plus 1 by 11 plus c. Therefore this is our answer. Option number C is our correct option. Question number 54. For any natural number m, we have to find the integration of this. So here, for solving this integration, we have to divide this by x and multiply this with x. Then this is equal to integration of x to power 3m plus x to power 2m plus x to power m divided by x, and we multiply with x to here, 2x to power 2m plus 3x to power m plus 6 to power 1 by m dx. Now this is equal to integration of x to power 3m x to power minus 1 plus x to power 2m x to power minus 1 plus x to power m x to power minus 1. When we multiply x with this term, then we will get x 2x to power 2m to power 1 by m, which is equal to x to power m 2x to power 2m to power 1 by m. Similarly, we multiply with x with this term and x with that term. Then this we able to write as x to power m 2 x to power 2m plus x to power m 3 x to power m plus x to power m into 6 whole to power 1 by m dx. When we simplify this, then we will get x to power 3m into x to power minus 1, which is equal to x to power 3m minus 1. Similarly, we solve this term, this term, this term and also this term. Then this we able to write as integration of x to power 3m minus 1 plus x to power 2m minus 1 plus x to power m minus 1. Then this is equal to 2 x to power 2m plus m plus 3 x to power m plus m plus 6x to power m whole to power 1 by m dx, which is equal to integration of x to power 3m minus 1 plus x to power 2m minus 1 plus x to power m minus 1 and 2x to power 3m plus 3x to power 2m plus 6x to power m dx. Now we take this b t. So 2x to power 3m plus 3x to power 2m plus 6x to power m equal to t. Differentiating both the side with respect to x, then we will get 6m x to power 3m minus 1 plus 6m x to power 2m minus 1 plus 6m x to power m minus 1 equal to dt by dx. Now we take 6m common from this 3 term. 6m x to power 3m minus 1 plus x to power 2m minus 1 plus x to power m minus 1 dx equal to dt. Then we have x to power 3m minus 1 plus x to power 2m minus 1 plus x to power m minus 1 dx, which is equal to dt by 6m. Now in the place of this with dx, we are able to write dt by 6m, and in the place of this we write t. Then this integration we are able to write as integration of t to power 1 by m dt by 6m, which is equal to 1 by 6m. This is t to power 1 by m plus 1 divided by 1 by m plus 1 plus c, which is equal to 1 by 6m m divided by m plus 1 t to power m plus 1 by m plus c. Now m cancel. Now in the place of t we are able to write this, that is this one. So which is equal to 1 by 6 m plus 1. T means 2x to power 3m plus 3x to power 2m plus 6 x to power m to power m plus 1 by m plus c. So this is our answer. Question number 55. In this question, I is equal to this and j which is equal to this, and c is our arbitrary constant. Then we have to find the value of I minus j. So let's see the solution of this question. So first of all, we convert all the negative from j to positive. Let's see. So j is equal to integration of 1 by e to power x divided by 1 by e to power 4x plus 1 by e to power 2x plus 1 dx. Now which is equal to integration of 1 by e to power x divided by, so we take the LCM of this. So LCM is equal to e to power 4x, and this we are able to write 1 plus e to power 2x plus e to power 4x whole dx. Then which is equal to integration of 1 by e to power x into e to power 4x divided by e to power 4x plus e to power 2x plus 1 dx. Then we cancel e to power x to e to power 4x, we will get e to power 3x. Then j is equal to, then j which is equal to e to power 3x divided by e to power 4x plus e to power 2x plus 1 dx. Now we are going to find I minus j. So I minus j which is equal to integration of e to power x divided by e to power 4x plus e to power 2x plus 1 minus e to power 3x divided by e to power 4x plus e to power 2x plus 1 dx, which is equal to now integration of e to power x minus e to power 3x divided by e to power 4x plus e to power 2x plus 1 dx. After that, we are taking e to power x common from these two terms.
then we will get integration of e to power x 1 minus e to power 2x divided by e to power 4x plus e to power 2x plus 1 dx. After that we put e to power x equal to t. Then we will get put e to power x equal to t. Then we will get e to power x dx, which is equal to dt. So this integration we able to write as I minus j, which is equal to integration of 1 minus t square divided by t to power 4 plus t square plus 1 dt. If you take t square common from numerator and denominator, then we will get integration of t square 1 by t square minus 1 divided by t square, then t square plus 1 plus 1 by t square dt. Now t square and t square cancel, we will get integration of 1 by t square minus 1 divided by t square plus 1 by t square plus 1 dt. After that we arrange our denominator. So this we able to write as integration of 1 by t square minus 1 t square plus 1 by t square plus, in the place of 1 we able to write 2 minus 1 dt. In denominator this we able to write t plus 1 by t whole square, which we able to write t square plus 1 by t square plus 2 into t into 1 by t, which is equal to t square plus 1 by t square plus 2. So this is equal to integration of 1 by t square minus 1 divided by t plus 1 by t whole square minus 1 dt. Now we put t plus 1 by t equal to z. If you differentiate, then we will get 1 minus 1 by t square dt equal to dz. So this we able to write as 1 by t square minus 1 dt equal to minus dz. So therefore this integration we able to write as I minus j, which is equal to integration of minus dz divided by z square minus 1, which is equal to minus we taking out dz divided by z plus 1 z minus 1, which we able to write minus 1 by 2 integration of z plus 1 minus z minus 1 divided by z plus 1 z minus 1 dz. If you solve the numerator, then you will get same like this. So that is z plus 1 minus z minus 1, which is equal to z plus 1 minus z plus 1, which is equal to 2, and this 2 we cancel with that 2. Therefore I minus j, which is equal to minus 1 by 2. Integration of z plus 1 divided by z plus 1 z minus 1 minus z minus 1 divided by z plus 1 z minus 1 dz. Now this cancel with this term and this cancel with this term. Then we will get minus 1 by 2 integration of 1 divided by z minus 1 dz minus integration of 1 divided by z plus 1 dz. So which is equal to minus 1 by 2. Integration of 1 divided by z minus 1, we will get log of z minus 1 minus log of z plus 1 plus c. If you take minus inside the bracket, then we will get log z plus 1 minus log z minus 1 plus c. If you apply log property here, that is log m minus log n, which is equal to log m by n. So then this we able to write as 1 by 2 log z plus 1 divided by z minus 1 plus c. So we know that z we able to write as t plus 1 by t. So in the place of z we able to write t plus 1 by t. So 1 by 2 log, in the place of z we write t plus 1 by t plus 1 divided by t plus 1 by t minus 1 plus c. So again we know that in the place of t we are able to write e to power x. So this is equal to 1 by 2 log e to power x plus 1 by e to power x plus 1 divided by e to power x plus 1 by e to power x minus 1 plus c. So I minus j we are able to write as 1 by 2 log e to power 2x plus 1 plus e to power x divided by e to power x and whole divided by e to power 2x plus 1 minus e to power x divided by e to power x plus c, which we are able to write as 1 by 2 log e to power 2x plus e to power x plus 1 divided by e to power 2x minus e to power x plus 1 plus c. So this is our answer. If you check the option number B is our correct option. Question number 56. In this question, f of x is given and g of x is also given in term of f and f occur n times. Then we have to find the value of this, that is integration of x to power n minus 2 gx dx. Let's see the solution of this question. So here f of x, which is equal to x upon 1 plus x to power n to power 1 by n. Now with the help of f of x we are going to find f of f x, which we are able to write f of x, which is equal to f of x divided by 1 plus f of x to power n whole to power 1 by n. Now in the place of f of x we put this value, which is equal to x divided by 1 plus x to power n to power 1 by n divided by 1 plus x upon 1 plus x to power n to power n whole to power 1 by n, which is equal to now x divided by 1 plus x to power n whole to power 1 by n divided by 1 plus x to power n divided by 1 plus x to power n whole to power 1 by n. So that x divided by 1 plus x to power n to power 1 by n divided by 1 plus x to power n plus x to power n divided by 1 plus x to power n whole to power 1 by n. After that we cancel this part to that part. Then we will get x upon 1 plus 2x to power n to power 1 by n. Therefore, f of x, which is equal to this. Similarly, we are going to find f of f x, which is equal to f of x. Now, which we are able to write as f of x divided by 1 plus f of x to power n whole to power 1 by n. So we know that f of x, which is equal to this, and this value we put it here as well as here, then which is equal to x divided by 1 plus 2x to power n to power 1 by n divided by 1 plus x upon 1 plus 2x to power n to power n whole to power 1 by n. If you solve this, then we will get x upon 1 plus 2x to power n to power 1 by n divided by 1 plus 2x to power n plus x to power n to power 1 by n upon 1 plus 2x to power n to power 1 by n. So this and that cancel again, then we will get x upon 1 plus 3 x to power n to power 1 by n. So therefore this, which is equal to x upon 1 plus 3x to power n to power 1 by n. So we have f of x, which is equal to x upon 1 plus x to power n to power 1 by n, and f of x, which is equal to x upon 1 plus 2x to power n whole to power 1 by n. FO x, which is equal to x upon 1 plus 3x to power n to power 1 by n. Similarly, it goes up to n times, then we will get which is equal to x upon 1 plus n x to power n to power 1 by n. As per given question, this is equal to g of x. So, we are able to write g of x equal to x upon 1 plus n x to power n whole to power 1 by n. Now we are going to find integration of x to power n minus 2 g of x. Now we take the value of the g of x from here. Now which is equal to integration of x to power n minus 2 and gx, which is equal to x upon 1 plus n x to power n to power 1 by n dx, which is equal to integration of x to power n minus 1 upon 1 plus n x to power n to power 1 by n dx. Now we put this equal to t to power n, then put 1 plus n x to power n equal to t to power n, differentiating both sides with respect to x, then we will get 0 plus n x to power n minus 1 dx, which is equal to n t to power n minus 1 dt. This implies that x to power n minus 1 dx, which we will get 1 by n t to power n minus 1 dt. Now in the place of x to power n minus 1 dx, we put this value, and in the place of this we will put t to power n. So above integration we are able to write integration of 1 upon n t to power n minus 1 divided by t to power n to power 1 by n dt, which is equal to 1 by n integration of t to power n minus 1 divided by t dt, which is equal to 1 by n integration of t to power n minus 2 dt, which is equal to now 1 by n t to power n minus 1 divided by n minus 1 plus c. We know that t to power n we are able to write as 1 plus n x to power n. So t we are able to write as 1 plus n x to power n to power 1 by n. So in the place of t we are able to write this value, which is equal to 1 upon n minus 1 1 plus n x to power n to power 1 by n and to power n minus 1 plus c, which is equal to 1 upon n minus 1 1 plus n x to power n to power 1 minus 1 by n plus c. So this is our answer. Option number A is our correct option. Question number 57. In this question we are going to find limit t tends to 0, 1 raised to power 1 divided by sine square t plus 2 raised to power 1 divided by sine square t plus up to n raised to power 1 divided by sine square t whole to power sine square t is equal to. Let's see the solution of this question. We will take 1 divided by sine square t equal to y. So here we will take 1 divided by sine square t, which is equal to y. This implies that we are able to write sine square t equal to 1 by y. After that we change the limit, which is when we will take t equal to 0, then y is equal to 1 divided by sine square 0, which is equal to 1 by 0, which we will take as a infinity. So when we take t equal to 0, then we will get y equal to infinity. Therefore we are able to write this limit as limit y tends to infinity 1 to power y plus 2 to power y plus it's going on plus n minus 1 to power y plus n to power y whole to power 1 by y. Now from this we are able to take n to power y as a common, which is equal to limit y tends to infinity n to power y. We are able to write this as 1 by n to power y plus 2 by n to power y plus n minus 1 divided by n to power y plus n to power y by n to power y whole to power 1 by y. After that we are able to take out n to power y outside this bracket. Then we are able to write limit y tends to infinity n to power y to power 1 by y, 1 by n to power y plus 2 by n to power y plus it's going on plus n minus 1 by n to power y plus this we are able to write as 1 to power 1 by y. After that this y and this y cancel and we are able to write this as n limit y tends to infinity 1 by n to power y plus 2 by n to power y plus n minus 1 by n to power y plus 1 to power 1 by y. So here y tends to infinity, so in the place of y we put infinity, which is n 1 by n to power infinity plus 2 by n to power infinity plus
n minus 1 by n to power infinity plus 1 divided by infinity. So we know that any fraction to power infinity tends to 0. So this term all are equal to 0. And also we know that 1 divided by infinity, which is equal to 0. Therefore this is equal to n 0 plus 0 plus 0 plus 1 to power 0, which is equal to n into 1 to power 0, which is equal to n. So our answer is equal to n. So option number B is our correct option. Question number 58. We are going to find the shortest distance between these two lines, and the line is given in Cartesian form. See, when we compare these two lines with these two given standard form, then we are able to write as then x1, which is equal to 2, y1, which is equal to minus 1, z1, which is equal to 6. Similarly, x2 equal to 6, y2 equal to 1, z2 equal to minus 8, a1 equal to 3, b1 equal to 2, b2 which is equal to minus 2, and c2 equal to 0. We have to take care while taking the value y2 and b2, which we will take from here, which is we are able to write in that way. Now all this value we put it here, then we will get, therefore shortest distance, which is equal to x2 minus x1, that is 4, y2 minus y1, that is 2, z2 minus z1, that is minus 14, that is 4, 2 minus 14. a1 is 3, b1 is 2, c1 is 2, a2 is 3, b2 is minus 2, and c2 which is equal to 0. Similarly, we put the value in denominator also, then we will get this. Now solve the determinant with the help of first row, then we will get shortest distance, which is equal to 4 into 4 minus 2 into minus 6 plus minus 14 into minus 12 divided by unit vector of 4i cap plus 6j cap minus 12k cap, then which is equal to 16 plus 12 plus 168 divided by, we will get root over 4 square plus 6 square minus 12 square, then which is equal to 196 divided by root over 296, which is equal to 196 divided by 14, which is equal to 14. So our answer is 14. So option number C is our correct option. Question number 59. We have to find the value of tan inverse of this plus sec inverse of this, which is equal to. Let's see the solution of this question. So here we have to find the value of
tan inverse of this plus sec inverse of this. First of all, we simplify this part and this part here, which is 1 plus root 3 divided by 3 plus root 3. If you rationalize this, then you will write in that way: 3 minus root 3. If you simplify, then you will get 3 minus root 3 plus 3 root 3 minus 3 divided by, if you solve this with the help of a plus b, a minus b, which is equal to a square minus b square, this we able to write as 3 square minus root 3 square. Now 3 and 3 cancel, minus root 3 plus 3 root 3, we will get 2 root 3. Then this is equal to 2 root 3 divided by 3 square is 9 and root 3 square equal to 3, which is equal to 6. So divided by 6. Then 2 3 times it's 6, which is equal to root 3 by 3. If you rationalize root 3 once again, then you will get 3 root 3, then which is equal to 1 by root 3. So after simplifying this, you will get 1 upon root 3. After that, we simplify this here. Let's see. Root over 8 plus 4 root 3 divided by 6 plus 3 root 3. Now rationalize, then we able to write 6 minus 3 root 3 divided by 6 minus 3 root 3, which is equal to which is equal to root over 48 minus 24 root 3 plus 24 root 3 minus, which is equal to root over 48 minus 24 root 3 plus 24 root 3 minus 36 divided by 36 minus 27. Now minus 24 root 3 plus 24 root 3 cancel, then 48 minus 36 we will get 12, and 36 minus 27 we will get 9. Then this we able to write as root over 12 upon 9. Now 3 4 times 12, 3 3 times 9, then which is equal to root over 4 by 3, which we able to write 2 upon root 3. After simplifying this, we will get 2 upon root 3. Then in the place of this, we able to write 1 upon root 3, and in the place of this, we able to write 2 upon root 3. And this is equal to tan inverse 1 by root 3 plus sec inverse 2 by root 3. So we know that tan pi by 6, which is equal to 1 by root 3, and sec pi by 6, which is equal to 2 by root 3. So in the place of 1 by root 3 we are able to write 10 pi by 6, and in the place of 2 by root 3 we are able to write sec pi by 6. So we are able to cancel tan inverse with tan and sec inverse with sec. Then we are able to write as pi by 6 plus pi by 6, which is equal to 2 pi by 6, which is equal to pi by 3. So pi by 3 is our answer. So option number C, which is our correct option. Question number 60. We have to find the value of this. Let's see the solution of this question. Let we take I, which is equal to this. So I, we take 8 by pi integration of 0 to pi by 2 cos x to power 2023 divided by sin x to power 2023 plus cos x to power 2023 whole dx, and we take this be equation number 1. Now using property 0 to a f of x dx, which we are able to write 0 to a f of a minus x dx. So equation number 1 we are able to write as 8 by pi integration of 0 to pi by 2 cos pi by 2 minus x to power 2023 divided by sin pi by 2 minus x to power 2023 plus cos pi by 2 minus x to power 2023 whole dx. So we know that cos pi by 2 minus x, which we are able to write as sin x. Similarly, sin pi by 2 minus x, we are able to write cos x. We change these two sin x, this cos x and this sin x. This implies that we are able to write as I equal to 8 by pi integration of 0 to pi by 2 sin x to power 2023 divided by cos x to power 2023 plus sin x to power 2023 whole dx, and we take this be equation number 2. Now adding equation 1 and 2, we have then I plus I, which is equal to 8 by pi integration of 0 to pi by 2 cos x to power 2023 divided by sin x to power 2023 plus cos x to power 2023 plus sin x to power 2023 divided by cos x to power 2023 plus sin x to power 2023 whole dx. So this implies that we will get 2I equal to 8 by pi integration of 0 to pi by 2. We will get cos x to power 2023 plus sin x to power 2023 divided by cos x to power 2023 plus sin x to power 2023 whole dx. Now this and this cancel. We will get 2I, which is equal to 8 by pi integration of 0 to pi by 2 dx, which is equal to 8 by pi. We will get x 0 to pi by 2 implies that 2I, which is equal to 8 by pi, that is pi by 2 minus 0, which is equal to 8 by pi into pi by 2, which is equal to 4. So 2I equal to 4 implies that I equal to 2. So 2 is our answer. So option number A is our correct option. Question number 61. We have to find the value of this, that is 12 integration of 0 to 3 modulus of x square minus 3x plus 2 whole dx. Let's see the solution of this question. So let we take I, which is equal to 12 integration of 0 to 3 modulus of x square minus 3x plus 2 whole dx. So we are able to break this quadratic equation as x square minus 2x minus x plus 2, which we are able to write as x minus 2 minus 1 x minus 2, which is equal to x minus 1 x minus 2. So in this number line, this is 1, this is 2. So this part minus infinity to 1, that is positive, and 1 to 2, that is negative, and 2 to infinity, that is positive. So here this is positive, this is negative, and this again positive. So our x belongs to 1 and 2 when f of x less than 0. Our x belongs to r minus 1, 2 when f of x greater than equal to 0. Therefore this our I we able to write as 12 0 to 1 f of x dx minus 1 to 2 f of x dx plus 2 to 3 f of x dx. So therefore I we able to write as 12 integration of 0 to 1 x square minus 3x plus 2 dx minus 1 to 2 x square minus 3x plus 2 dx plus integration of 2 to 3 x square minus 3x plus 2 dx. If you integrate this, that is integration of x square minus 3x plus 2 dx, you will get x cubed by 3 minus 3x square by 2 plus 2x plus c. Similarly, integration of this and this are also same, only the limit is different. Now, so which is equal to now 12, that is x cubed by 3 minus 3x square by 2 plus 2x, limit is 0 to 1, minus x cubed by 3 minus 3x square by 2 plus 2x, limit is 1 to 2, plus x cubed by 3 minus 3x square by 2 plus 2x, now limit is 2 to 3. So after that we put the limit, then we will get 12, 1 by 3 minus 3 by 2 plus 2, minus, if you put the limit 2 in the place of x, then we will get 8 by 3 minus 12 by 2 plus 4. Now after that we put the limit 1 here, then we will get same as this one. So this is equal to 1 by 3 minus 3 by 2 plus 2 plus, now we put the limit 3 here, then we will get 27 by 3 minus 27 by 2 plus 6, minus, if you put 2 limit here, then this is same as this, so we are able to write this as 8 by 3 minus 12 by 2 plus 4. After that we take the LCM and solve, then we will get 12, LCM is 6 here, then we will get 2 minus 9 plus 12, minus, so LCM here, that is 6, then we are able to write 6, that is 16 minus 36 plus 24, minus, again LCM is 6, we will get 2 minus 9 plus 12. So again here LCM is 6, then we will get LCM is 6, then this is 54 minus 81 plus 36, then minus, LCM is 6, then we will get 16 minus 36 plus 24. So which is equal to 12, that is 14 minus 9 by 6 minus of 40 minus 36 by 6 minus 14 minus 9 by 6 plus 90 minus 81 by 6 minus 40 minus 36 by 6. Now which is equal to 12, that is 5 by 6 minus 4 by 6 minus 5 by 6 plus 9 by 6 minus 4 by 6, which is equal to now 12. 5 by 6 minus 1 by 6 plus 5 by 6, which is equal to 12. 10 by 6 plus 1 by 6. So which able to write 12 into 11 by 6. So 6 2 times 12, then we able to write 2 into 11, which is equal to 22. So 22 is our answer. So option number D is our correct option. Question number 62. We have to find the area enclosed by the curve this and the given line this. Let's see the solution of this question. So here the given curve, that is y square plus 4x equal to 4, which we are able to write as y square equal to minus 4x plus 4, and the given line, which is given as y minus 2x equal to 2. We know that equation of the parabola, if y square equal to minus 4ax, then we draw the parabola in that way. But when the equation is like this, y square minus 4ax plus 4, then we draw the parabola in that way. Now we draw the graph of this parabola. Then this is the y-axis and this is x-axis. Now parabola like this. So here when we take x equal to 0, then y square you will get 4, that means y equal to plus minus 2. So this point we will get 0 2, and this point we will get 0 minus 2. And when we take y equal to 0, then we will get 4x equal to 4, x equal to 1. So this point is 1 0. Now we draw the graph of this line. When we take x equal to 0, then you will get y equal to 2. So one point we will get here, x equal to 0 and y is equal to 2. After that, when we take y equal to 0, then we will get minus 2x, which is equal to 2. That means x equal to minus 1. So when you get y equal to 0, x equal to, we will get minus 1 here. So our line passed through 0 2 to minus 1 0. Now we need coordinate of this intersecting point of line and curve. Now for this we find the value of x from the line and put the value of x in the equation of parabola. Implies that y minus 2 we are able to write 2x. So the value of x we are able to write y minus 2 by 2. Now this value we put it here. then we will get y square equal to minus 4 y minus 2 by 2 plus 4. This implies that y square equal to minus 2y plus 4 plus 4, which is equal to y square plus 2y minus 8 equal to 0. If you solve this, then you will get y square plus 4y minus 2y minus 8 equal to 0. That is y plus 4 minus 2 y plus 4 equal to 0. So y plus 4 and y minus 2 equal to 0. That implies that y equal to minus 4 and 2. Take y equal to minus 4 and we put it here, then we will get x equal to minus 4 minus 2 by 2, that is minus 6 by 2, that is minus 3. So we will get this point, that is minus 3 minus 4. When we take y equal to 2 and put it here, then we will get x equal to 2 minus 2 divided by 2, which is equal to 0 by 2 equal to 0. So this point we will get 0, 2. After finding the intersecting point of line and curve, we are going to find the area enclosed by the curve and the line. Required area is equal to integration of minus 4 to 2. Equation of the parabola in term of y minus equation of the line in term of y whole dy. When we find equation of the parabola in term of y, then we will write 4x, which is equal to 4 minus y square, x equal to 4 minus y square divided by 4. The value of x we put it here. Then we will get integration minus 4 to 2, 4 minus y square by 4 minus y minus 2 by 2 whole dy, which is equal to minus 4 to 2, that is 1 minus y square by 4 minus y by 2 plus 1 dy, which we are able to write as minus 4 to 2, 1 plus 1, that is 2 minus y square by 4 minus y by 2 dy. If you integrate this, then you will get 2y minus y cube by 12 minus y square by 4. Then we are able to write 2y minus y cube by 12 minus y square by 4 minus 4 to 2. We put the limit, then we will get 2 into 2 minus 2 cube by 12 minus 2 square by 4 minus 2 into minus 4 plus minus 4 whole cube divided by 12 plus minus 4 whole square divided by 4. After that we will get, that is 4 minus 8 by 12 minus 4 by 4 plus 8 minus 64 by 12 plus 16 by 4. Now we cancel some term like 4 2 times 8, 4 3 times 12, 4 1 times 4, 4 1 times 4, 4 1 times 4, 4 4 times 16, 4 3 times 12, 4 16 times 64, then which is equal to 4 minus 2 by 3 minus 1 plus 8 minus 16 by 3 plus 4. Now 4 plus 8, that is 12, 12 plus 4, that is 16, 16 minus 1, that is 15, and minus 2 by 3 and minus 16 by 3, we will get minus 18 by 3. Then 3 6 times 18, we will get 15 minus 6, that is 9. 9 is our answer. So option number C is our correct option. Question number 63. For three positive integer p, q, r, we have x to power pq square, which is equal to y to power qr, which is equal to z to power p square q, and r is equal to pq plus 1, such that the given sequence are in AP with common difference 1 by 2. Then we have to find the value of r minus p minus q. Let's see the solution of this question. So here, given that x to power pq square, which is equal to y to power qr, which is equal to z to power p square q, which we will take lambda. So now we are able to write lambda equal to x to power pq square. We know that if m equal to n to power t, if you take the log both the side, then we will get log n m, which is equal to t. So this we are able to write as now log x lambda, which is equal to pq square. If we take log pq, which is equal to t, change their position, then you will get log qp, which is equal to 1 by t. This we are able to write as log lambda x, which is equal to 1 by p q square. Similarly, we are able to write log lambda y, which is equal to 1 by qr, and log lambda z, which is equal to 1 by p square r. Now it's given that these are in AP with common difference 1 by 2. We take this be question number 1. Now we are going to find log yx, log zy, and log xz. Log of yx we are able to write as, so we know that log of mn we are able to write as log pn divided by log pm. So here we are able to write as log lambda x divided by log lambda y. So we know the value of log lambda x and log lambda y, which we find above, which is equal to 1 by pq square divided by 1 by qr, which we able to write qr divided by pq square, which is equal to r divided by pq. Similarly, we find the value of log zy, which we able to write as log lambda y divided by log lambda z, which we able to write as 1 upon qr divided by 1 p square r, which is equal to p square r divided by qr, which is equal to p square q. And log xz we able to write as log lambda z divided by log lambda x, which is equal to 1 divided by p square r divided by 1 divided by pq square, which is equal to pq square divided by p square r, which is equal to q square by pr. Therefore, this AP we able to write as, in the place of this we put this value, in the place of this we put this value, and in the place of this we put this value. Then equation number 1 implies AP 3r divided by PQ, 3p square divided by Q, 7q square divided by PR. And the common difference of this AP is given, which is equal to 1 by 2. So we are able to write as 3r divided by PQ minus 3, which is equal to 1 by 2. If we simplify, then we will get 3r minus 3pq divided by pq, which is equal to 1 by 2. Then 6r minus 6pq equal to pq. So 6r, which is equal to pq plus 6pq. Therefore, r equal to 7pq by 6. Therefore, r is equal to 7pq by 6. Also given in question, r equal to pq plus 1. Now we know that the value of r, which is 7pq by 6, equal to pq plus 1. So 7pq equal to 6pq plus 6. So 7pq minus 6pq equal to 6. So pq, which is equal to 6. Therefore, the value of r we will get r equal to 6, that is pq plus 1, which is equal to 7. Now we also able to write this minus this term equal to 1 by 2, and similarly this minus this term which is also equal to 1 by 2, that is 3p square by q minus 3r by pq, which is equal to 1 by 2, and 7q square divided by pr minus 3p square by q, which is also equal to 1 by 2. Now here we know that the value of r, which is equal to 7, and the value of pq, which is equal to 6. Therefore this we are able to write as 3p square by q minus 3 into 7 divided by 6 equal to 1 by 2, which is equal to now 3p square by q equal to 1 by 2 plus 7 by 2, that is 3p square by q, which is equal to 8 by 2, which we are able to write as 3p square by q equal to 4. Now the value of 3p square by q, we put it here. Then we are able to write 7q square divided by pr minus 4 equal to 1 by 2. 7q square. P in the place of r we write 7 equal to 1 by 2 plus 4, which is equal to q square by p equal to 9 by 2. So from this we will take p equal to 2 and q square equal to 9. This implies that q we are able to take plus minus 3. So we will take q equal to 3 because it's given that q is a positive integer. Therefore r minus p minus q, which is equal to r is 7, p is 2 and q is 3, which we will get 2. So 2 is our answer. Option number A is our correct option. Question number 64. F of x is given, which is equal to x square sine 1 by x when x is not equal to 0. F of x equal to 0 when x is equal to 0. We have to check the condition A, B, C, D, which one of is correct at x equal to 0. Let's see the solution of this question. So here f of x is given, which is equal to f of x, which is equal to x square sine 1 by x when x is not equal to 0, and f of x is equal to 0 when x equal to 0. First of all, we have to check the continuity at x equal to 0. Let's see. At x equal to 0, left-handed limit x tends to 0 to power minus. That means the value of x is slightly less than 0, which is approach to 0. F of x, which is equal to limit x tends to 0 minus. That means it's not equal to 0. Then we will take the function x square sine 1 by x. Now put x is equal to 0 minus h. H is the small value which is minus from 0, so that the value of the x comes less than 0. As x tends to 0 to power minus, we are able to write h tends to 0. Therefore, limit x tends to 0 minus x square sine 1 by x, we are able to write as limit h tends to 0. In the place of x, we are able to write 0 minus h whole square sine 1 upon 0 minus h, which is equal to, we are able to write limit h tends to 0 minus h whole square sine minus 1 by h, which is equal to limit h tends to 0 h square minus sine 1 by h. If you put the limit, then it will become 0 square minus sine 1 by 0. So we know that the value of sine 1 by 0 lies between minus 1 to 1. So which we are able to write 0 into minus 1 to 1, which is equal to 0. So left-handed limit, which we will get 0. Now we solve right-handed limit, that is limit x tends to 0 plus f of x. 0 plus means it's slightly greater than 0. Then we will take limit x tends to 0 plus, which is not equal to 0. So we will take the same function, that is x square sine 1 by x. Now we put x equal to 0 plus h. H is some small value, we plus with 0, so that we will get the value of x is slightly greater than 0. As x tends to 0 plus, we are able to write h tends to 0. Therefore, limit x tends to 0 plus x square sine 1 by x, we are able to write this as limit h tends to 0, 0 plus h whole square sine 1 by 0 plus h, which is equal to limit h tends to 0, that is h square sine 1 by h. So if you put the limit, you will get 0 square sine 1 by 0. So we know that the value of sine 1 by 0 lies minus 1 to 1. So this we are able to write as 0 into minus 1 to 1. So this is obviously 0. Therefore right-handed limit is also equal to 0. Now f of 0 is already given 0. Therefore we will get left-handed limit equal to right-handed limit, which is equal to f of 0. So the function f of x is continuous function at x equal to 0. Now we check the differentiability of function at x equal to 0. So left-handed differentiable, that is limit h tends to 0 f of 0 minus h minus f of 0 divided by h, which is equal to limit h tends to 0 f of 0 minus h, we are able to write that is 0 minus h whole square sine 1 divided by 0 minus h, and f of 0 means 0 only, divided by h, which is equal to limit h tends to 0, that is minus h whole square sine minus 1 by h divided by h, which is equal to limit h tends to 0 h square minus sine 1 by h divided by h. Now 1h we cancel from here, then we are able to write as limit h tends to 0 h minus sine 1 by h, which is equal to 0 into minus sine 1 by 0, which is equal to 0. So left-handed derivative we will get 0. Right-handed derivative we write limit h tends to 0 f of 0 plus h minus f of 0 divided by 0, which is equal to limit h tends to 0, we are able to write this as 0 plus h whole square sine 1 divided by 0 plus h, and we know that f of 0, that is 0 divided by h, which is equal to limit h tends to 0, we are able to write this as h square sine 1 by h divided by h, which is equal to 0 into sine 1 by 0 equal to 0. So therefore left-handed derivative equal to right-handed derivative, so the function f of x is differentiable. So till now we will get the function f of x is continuous and differentiable. So the option number A is not correct, and option number D is also not correct. So our answer is B or C. For that we have to find f dash x and check the continuity of the function. So f of x, which is given, that is x square sine 1 by x. Now for finding f dash x, we use the product rule, that is x square the dx of sine 1 by x plus sine 1 by x the dx of x square. If we solve this, then we will get, that is x square, that is cos 1 by x minus 1 by x square plus sine 1 by x, that is 2x term. Now we cancel this with this term, then we write f dash x, which is equal to minus cos 1 by x plus 2x sine 1 divided by x. Therefore, f dash x we are able to write as minus cos 1 by x plus 2x sine 1 by x when x not equal to 0, and f dash x equal to 0 when x equal to 0. Now we are going to prove the continuity at x equal to 0. Left-handed limit, that is limit x tends to 0 to power minus cos 1 by x plus 2x sine 1 by x. So put x equal to 0 minus h as x tends to 0 minus, we are able to write h tends to 0. Now this limit we are going to write as limit h tends to 0 minus cos 1 divided by 0 minus h plus 2 in the place of x we will write 0 minus h sine 1 divided by 0 minus h, which is equal to limit h tends to 0 minus cos minus 1 by h plus 2 minus h sine minus 1 by h. If you put the limit, then we will get cos 1 by 0 plus 2 into 0 sine minus 1 by h. We know that this value is from minus 1 to 1 and this term is equal to 0. So we are able to write this as minus 1 to 1 and this term is 0, which is equal to minus 1 to 1. Now similarly, right-handed limit we are able to write as limit h tends to 0 minus cos 1 divided by 0 plus h plus 2 0 plus h sine 1 divided by 0 plus h, which is equal to limit h tends to 0 minus cos 1 by h plus 2h sine 1 by h. After that we put the limit, then we will get minus cos 1 by 0 plus 2 into 0 sine 1 by 0. So which is equal to minus 1 to 1. Now we find f dash x at x equal to 0, which is equal to 0. So f dash 0, which is equal to 0. this is our left-handed limit and this is our right-handed limit. So left-handed limit equal to right-handed limit, but which is not equal to f dash 0. So f dash x is not continuous. So we will get f of x is continuous. F of x is differentiable and f dash x is not continuous. So option number B is our correct option. Question number 65. Prove that our left hand side which is equal to 4. Let's see the solution of this question. So here left hand side which is equal to tan 9 degree minus tan 27 degree minus tan 63 degree plus tan 81 degree. Now we rearrange the term, that is tan 9 degree plus tan 81 degree minus tan 27 degree plus tan 63 degree. Now we are going to change tan 81 degree to cot 9 degree and tan 63 degree to cot 27 degree. So we know that cot 90 degree minus theta which is equal to tan theta. Cot 90 degree minus 81 degree we are able to write as tan 81 degree. So cot 9 degree which we are able to write tan 81 degree. Similarly we write cot 90 degree minus 63 degree equal to tan 63 degree. This implies that cot 27 degree equal to tan 63 degree. So in the place of tan 81 degree we are able to write cot 9 degree, and in the place of tan 63 degree we are able to write cot 27 degree. Now this we are able to write as tan 9 degree plus cot 9 degree minus tan 27 degree plus cot 27 degree. So we know that tan theta we are able to write sin theta by cos theta, and cot theta we are able to write cos theta by sin theta equal to sin 9 degree divided by cos 9 degree plus cos 9 degree divided by sin 9 degree minus this is sin 27 degree divided by cos 27 degree plus cos 27 degree divided by sin 27 degree. If we simplify this, then we are able to write sin square 9 plus cos square 9 divided by cos 9 degree sin 9 degree minus sin square 27 plus cos square 27 divided by cos 27 degree sin 27 degree. So we know that sin square theta plus cos square theta, which is equal to 1. So in the place of this we are able to write 1, and in the place of this also we are able to write 1. So this is equal to 1 divided by sin 9 degree cos 9 degree minus 1 divided by sin 27 degree cos 27 degree. So we multiply to both numerator and denominator. Then this is sin 9 degree cos 9 degree. Similarly, 2 divided by 2 sin 27 degree cos 27 degree. Now we know that sin 2x, we are able to write 2 sin x cos x. So this is equal to 2 divided by sin 2 into 9 minus 2 divided by sin 2 into 27, which is equal to 2 divided by sin 18 minus 2 divided by sin 54, which is equal to 2 sin 54 degree minus sin 18 degree divided by sin 18 degree sin 54 degree. Now we know that sin x minus sin y, we are able to write as 2 cos x plus y by 2 sin x minus y by 2. Now we solve this with the help of this identity, then which is equal to 2 cos 54 plus 18 by 2 sin 54 minus 18 by 2 divided by sin 18 degree. So in the place of sin 54 degree we are able to write cos 90 degree minus 54 degree, which is equal to cos 36 degree. So this is cos 36 degree. Now 54 plus 18, which is equal to 72, divided by 2, which is equal to 36, and 54 minus 18, which is equal to 36, divided by 2, equal to 18 degree. Then which is equal to 2 cos 36 degree sin 18 degree divided by sin 18 degree cos 36 degree. Now we cancel sin 18 degree with sin 80 degree, cos 36 degree with cos 36 degree, which is equal to 2 into 2 equal to 4. Then which is equal to right hand side. Proof. Question number 66. Let S is a set whose element is given 1, 2, 3 and 4. Then we have to find the total number of unordered pair of the joint subset of S. Let's see the solution of this question. So here S is given, which is equal to 1, 2, 3, 4. Total number of element of S, which is equal to 4. So we have a formula to find the total number of unordered pair of the joint subset, which is equal to 3 raised to power n plus 1 divided by 2. Here n is equal to number of elements. Therefore, the total number of unordered pair of the joint subset of S, which is equal to 3 to power 4, that is the number of element, plus 1 divided by 2, which is equal to 3 raised to power 4, that is 81 plus 1 by 2, which is equal to 82 by 2, that is 41. So 41 is our correct answer. Option number D is our correct option. Question number 67. If the line this meet the plane this at a point P, then we have to find the distance P from the origin. Let's see the solution of this question. So here x plus 2y plus 3z equal to 15. This is the equation of plane, and we take this be equation number 1. And x minus 1 by 2 equal to y plus 1 by 3 equal to z minus 2 by 4. This is the equation of the line, and we take this be lambda, and this be equation number 2. Now equation 2 implies we are able to write x minus 1 by 2 equal to lambda, that is x minus 1 equal to 2 lambda, x equal to 2 lambda plus 1. So we will get x equal to 2 lambda plus 1. Similarly, the value of y we will get 3 lambda minus 1, and the value of z we will get 4 lambda plus 2. So it's given that the line meet at a plane at point P. Therefore, we are able to put the value of x, y and z in equation number 1. Therefore, equation number 1 implies that 2 lambda plus 1 plus 2 3 lambda minus 1 plus 3 4 lambda plus 2, which is equal to 15. This implies that we will get 2 lambda plus 1 plus 6 lambda minus 2 plus 12 lambda plus 6 equal to 15. Now 2 lambda plus 6 lambda it's 8 lambda plus 12 lambda it's 20 lambda, and 6 plus 1 it's 7 minus 2 it's 5. So this implies that we will get 20 lambda plus 5 equal to 15. This implies that 20 lambda equal to 15 minus 5 implies that lambda equal to 10 by 20, which is equal to 1 by 2. Therefore, coordinate of P, that is x, y, z, which we are able to write as 2 lambda plus 1, 3 lambda minus 1 and 4 lambda plus 2. If you put the value of lambda, then we will get this is 2 into 1 by 2 plus 1, 3 into 1 by 2 minus 1 and 4 into 1 by 2 plus 2, which we will get 2, 1 by 2 and 4. Therefore, distance of P from the origin, which is equal to root over 2 minus 0 whole square, that is 2 square plus 1 by 2 minus 0 whole square, that is 1 by 2 square, plus 4 minus 0 whole square, that is 4 square, which we will get 4 plus 1 by 4 plus 16, which is equal to root over 20 plus 1 by 4, which is equal to root over 81 by 4, which we able to write as 9 by 2 unit. So 9 by 2 is our answer. Option number C is the correct option. Question number 68. Let A and B be 2 3 cross 3 real matrices such that A square minus B square is invertible matrix if A to power 5 equal to B to power 5 and A cube B square which is equal to A square B cube, then we have to find the value of the determinant of the matrix A cube plus B cube. Let's see the solution of this question. So here it's given that A square minus B square is invertible matrix. Therefore, inverse of this, that is A square minus B square, is possible. Therefore, A square minus B square is non-singular matrix. So we able to write determinant of A square minus B square is not equal to 0, and we take this be equation number 1. Now again given that A to power 5 which is equal to B to power 5, we take this be equation number 2, and also given that A cube B square which is equal to A square B cube, we take this be equation number 3. Now we will take A cube plus B cube and multiply with A square minus B square. If you multiply, then we will get A to power 5 minus A cube B square plus B cube A square minus B to power 5. Now A to power 5 which is equal to B to power 5, we will get this from equation number 2, and also these two are equal, we will get this from equation number 3. So we able to cancel this with that and this term with this term, then which is equal to 0. Now taking determinant both side, then we will get determinant of A cube plus B cube A square minus B square equal to determinant of 0. This implies that determinant of A cube plus B cube, determinant of A square minus B square equal to 0. We know that determinant of A square minus B square is not equal to 0. For satisfying this equation, one of these two determinant should be 0. So this determinant is not possible to be 0. Ultimately we take this, that is determinant of A cube plus B cube is equal to 0. So determinant of A cube plus B cube which is equal to 0, because determinant of A square minus B square which is not equal to 0, which we will get from equation number 1. So our answer is determinant of A square plus B square which is equal to 0. So option number A, which is our correct option. Question number 69. P is given which is equal to this. The element of P which is equal to 1, 0, 1 by 2 and 1. Then we have to find the value of p raised to power 50. Let's see the solution of this question. So here p is given, which is equal to matrix of 1, 0, 1 by 2 and 1. Now we have to find p square, that is 1, 0, 1 by 2, 1 and 1, 0, 1 by 2, 1. Now we multiply first row with first column, first row with second column, and second row with first column, and second row with second column. Then we will get 1 plus 0, 0 plus 0, 1 by 2 plus 1 by 2, 0 plus 1. Now which is equal to 1 plus 0, that is 1, 0 plus 0, that is 0, half plus half, that is 1, and 0 plus 1, that is 1. So p square, which we will get this. Now we find p cube, which is equal to p square into p, which is equal to 1, 0, 1, 1, that is p square, and 1, 0, half 1, that is p. If you multiply this, then you will get 1 plus 0, 0 plus 0, 1 plus half, 0 plus 1, which is equal to 1, 0. You will get this 3 by 2, 1. If you observe the pattern p, p square, p cube, like that up to p to power n, then we are able to write p, that is 1, 0, 1 by 2, 1. P square, we will get 1, 0, 1, 1. P cube, we will get 1, 0, 3 by 2, 1. If you observe this, when you will get p to power 1, then you will get, that is 1 by 2, and the other element remain the same. When you will get p to power square, then you will get here 2 by 2, that is 1, and other element remain the same. When the power of p is 3, then you will get here 3 by 2, and other element remain the same. Similarly, when the power of p, which is equal to n, then you will get 1, 0, 1, that is n by 2. Therefore, we are able to write p to power n, which is equal to 1, 0, n by 2, 1. This implies that we are able to write p to power 50, which is equal to 1, 0, that is 50 by 2, and this is 1, which is equal to 1, 0, 25, and that is 1. This is our answer. So correct option is option number B. Question number 70. F of x is given in term of determinant and x belongs to 0 to pi. Then we have to find the maximum value of f of x. Let's see the solution of this question. F of x equal to this. We applying here row transformation, that is R2 tends to R2 minus R1 and R3 tends to R3 minus R1. Then we will get f of x, which is equal to, our first row remain the same, that is sin square x minus 2 plus cos square x, then cos 2x. For the second row, we will do r2 minus r1, that is this minus this, then we will get 2 here, this minus this, we will get 2 again, this minus this, we will get 0. So that is 2, 2, 0. For the third row, we will do r3 minus r1, that is this minus this, we will get 0, this minus this, we will get 2, this minus this, we will get 1. So that is 0, 2 and 1. After that, we expand this determinant with the help of first row. Then f of x, which is equal to sine square x 2 minus 0 minus 2 plus cos square x, that is 2 minus 0 plus cos 2x 4 minus 0, which is equal to 2 sine square x minus 4 plus 2 cos square x plus 4 cos 2x, which is equal to 2 sine square x plus 4 minus 2 cos square x plus 4 cos 2x. From this 2 term, we will take minus 2 common, then we will get minus 2 cos square x minus sin square x plus 4 cos 2x. So we know that cos square x minus sin square x, which is equal to cos 2x. Then this is equal to minus 2 cos 2x plus 4 cos 2x, which is equal to 2 cos 2x plus 4. So when x belongs to 0 to pi, the maximum value of cos 2x we will get 1. Then this is equal to 2 into 1 plus 4, which is equal to 6. So 6 is our answer. Option number D, which is our correct option. Question number 71. A straight line L with negative slope passes through the point 8, 2 and cuts the positive coordinate axis at a point P and Q. Then we have to find the absolute minimum value of OP plus OQ, whereas O is the origin. Let's see the solution of this question. So here, if you draw the line L which cuts the positive coordinate axis at point P, we take this point B x0 and Q, which is 0, y, and it's passed through the point 8, 2. The equation of line L we able to write as y equal to mx plus c, and we take this be question number 1. This line passed through the point 8, 2, then we able to write 2 equal to m8 plus c. This implies that c equal to 2 minus 8m. Therefore, equation 1 implies that y equal to mx plus, in the place of c, we are able to write 2 minus 8m. This we take equation number 2. When it's passed through point P, x 0, then equation number 2 implies that in the place of y we are able to write 0 equal to m. In the place of x we write x only, plus 2 minus 8m implies that mx we are able to write as 8m minus 2. Therefore, x equal to 8m minus 2 by m, which is equal to 8 minus 2 by m. Therefore, x equal to 8 minus 2 by m. And when it's passed through Q, that is 0y, then we are able to write y is y. In the place of m we will put 0 plus 2 minus 8m, that is y equal to 2 minus 8m. Therefore, OP plus OQ equal to, so OP means this distance and OQ means this distance, so which is equal to x plus y. For the value of x we are able to write this value, and for the value of y we are able to write this, then which is equal to 8 minus 2 by m plus 2 minus 8m, which is equal to 10 minus 2 by m minus 8m. Let you take this be our function, then we are able to write this as a fm, which is equal to this. For maxima or minima we have to find f dash m, which is equal to 0. If you differentiate this, that is dm of this, then you will get 0 minus 2 minus 1 by m square minus 8, which is equal to 2 divided by m square minus 8. Therefore, in left hand side we are able to write 2 divided by m square minus 8 equal to 0, which is equal to 2 by m square equal to 8. Therefore, it's cancelled with 4. Now, which is equal to 1 by m square equal to 4 implies that m square equal to 1 by 4. Therefore, m equal to plus minus 1 by 2. Now from this we will take the value of m, which is equal to minus 1 by 2, because it's given in question negative slope passed through the point 8, 2. So m is equal to minus 1 by 2. Now we have to check m equal to minus 1 by 2 is a point of maxima or minima. For that we have to find out f double dash m, which is equal to d dm of 2 by m square minus 8, which is equal to 2 minus 2 1 by m cube minus 0, which is equal to minus 4 by m cube. So at m equal to minus 1 by 2, f double dash minus 1 by 2, we will get minus 4 divided by minus 1 by 2 power 3, which we will get the positive value. Therefore, f dash minus 1 by 2 is positive. Therefore, m equal to minus 1 by 2 is a point of minima. So, absolute minimum value, that is OP plus OQ, which is equal to, we take that as a FM, which is equal to 10 minus 2 by m minus 8m. If you put the value of m here, that is 10 minus 2 divided by minus 1 by 2, that is the value of m, 8 minus 1 by 2, which you will get 10 plus 4 plus 4, which is equal to 18. Therefore, 18 is our answer. So option number C is our correct option. Question number 72. We find a point on the curve, that is x square plus 2y square equal to 6, whose distance from the line x plus y equal to 7 is minimum distance. Let's see the solution of this question. So here our given curve x square plus 2y square equal to 6 is a ellipse. If you convert this equation to standard form, that is x square divided by 6 plus y square by 3, which is equal to 1. Now this is the ellipse and a given line, that is x plus y equal to 7, which is equal to this. Now we need a point on the curve which is minimum distance from the line. This is only possible when you draw the tangent from that point and which is parallel to that line. Now we find the slope of the tangent. For that we differentiate this curve, that is ddx of x square plus 2y square equal to ddx of 6, which implies that ddx of x square, that is 2x, plus ddx of 2y square, that is 2 into 2y dy by dx, the dx of 6, that is 0. Now we take 2x from left hand side to right hand side. Then we are able to write this as 4y dy by dx, which is equal to minus 2x, which we are able to write as dy by dx, which is equal to minus 2x divided by 4y. Therefore, dy by dx we are able to write as minus x divided by 2y. Now our equation of the line, that is x plus y equal to 7, which we are able to write as y equal to minus x plus 7. If you compare this equation with y equal to mx plus c, then you will get slope m, which is equal to minus 1. Therefore, slope of this line m, which is equal to minus 1. Now we take tangent on the curve and the line both are parallel. Therefore, slope of the tangent, which is equal to slope of the line, we are able to write dy by dx, which is equal to m. So we know that dy by dx, which is equal to this, and the value of the m, which is equal to minus 1. This implies that minus x divided by 2y, which is equal to minus 1. This implies that x equal to 2y. Now x equal to 2y, we put this value in the equation of curve. Then we will get, that is 2y whole square. In the place of x we put 2y, and 2y square equal to 6. This implies that we will get 4y square plus 2y square, which is equal to 6, which implies that 6y square equal to 6, which is y square equal to 1. Therefore, y equal to plus minus 1. From here, we take y equal to 1 because the point lies on first quadrant. Therefore, y equal to 1. When you put y equal to 1 in here, then you will get the value of x, that is x equal to 2. So, required point that is 2, 1. This is our answer. So option number A is the correct option. Question number 73. If A is equal to matrix of alpha 2, 2, alpha and determinant of A cube, which is equal to 125, then we have to find the value of alpha. Let's see the solution of this question. So here A is given, which is equal to matrix of alpha 2, 2, alpha, and also given that determinant of A cube, which is equal to 125. So we know that determinant of A to power n we are able to write as determinant A to power n. Therefore, this we are able to write as determinant A cube equal to 5 to power cube, that is 125. This implies that determinant of A we are able to write 5. Therefore, A we are able to write this, which is determinant of alpha 2, 2, alpha, which is equal to 5. Now we solve this determinant with the help of first row. Then this we are able to write alpha square minus 4, which is equal to 5. So alpha square equal to 9. This implies that alpha equal to plus minus 3. So this is our answer. Option number C is our correct option. Question number 74. If P is equal to matrix of root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2, and A, which is equal to matrix of 1 1 0 1, and Q is given, which is equal to PA P transpose. Then we have to find the value of P transpose Q to power 2024 P. Let's see the solution of this question. So here P, which is equal to matrix of root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2. If we find P transpose, then we write P transpose, which is equal to root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2. Now we are going to find P transpose P, which is equal to root 3 by 2, minus 1 by 2, 1 by 2, root 3 by 2, and P, which is equal to root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2. Now we multiply P transpose P, which is equal to matrix of first row first column, which is equal to 3 by 4 plus 1 by 4. First row second column, which is equal to root 3 by 4 minus root 3 by 4. Second row first column, which is equal to root 3 by 4 minus root 3 by 4. Second row second column, which is equal to 1 by 4 plus 3 by 4. So if we simplify this, then we will get 1 here, here we will get 0, here we will get 0, here we will get 1, which is equal to 1 0 0 1, which is identity matrix. Now it's given that Q, which is equal to P A P transpose. Therefore we are going to find P transpose Q to power 2024 P, which is equal to, this we are able to write P transpose Q into Q into Q. So in this way it's going on 2024 times. So in the place of Q we are able to write PAP transpose. So this is equal to P transpose, in the place of Q we are able to write PA P transpose, again PA P transpose. It's going on up to 2024 times P. Now we are able to write P transpose P, this is A, again P transpose P, again this is A, P transpose P, and it's going on up to 2024 times. So we know that P transpose P we are able to write identity matrix. So in the place of P transpose P we are able to write I. Then we have A into A into A, and it's going up to 2024 times, then which is equal to A to power 2024. Now we are able to write P transpose Q to power 2024 P, which is equal to A to power 2024. We take this be equation number 1. Now we are going to find a to power 2024. For this we take the help of a. Therefore a is given, which is equal to 1101. Now we are going to find a square, that is a into a, which is equal to 1101 into 1101. If you multiply this, then we will get 1201. Similarly, we are going to find a cube, which is equal to a square into a, which is equal to 1201 into 1101. If you multiply again, you will get 1301. Now we check the behavior of our final product. When a to power 1, then this element we will get 1. When a to power 2, then this element we get 2, other remain same. When a to power 3, then this element we will get 3, other remain same. So in this way, if you proceed, then we will get a to power 2024, which we are able to write as 1 2024 01. So a to power 2024, which we will get 1 2024 0 and 1. So this is our answer. Option number B is correct option. Question number 75. The number of 3 cross 3 matrices A whose entries are either 0 or 1, for which the system A matrix of x, y, z, which is equal to matrix of 1, 0 and 0, has exactly 2 distinct solutions. Let's see the solution of this question. So here given that order of matrix A, which is equal to 3 cross 3. Let you take matrix A, which is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Now it's given that A matrix of x, y, z equal to 1, 0, 0 has 2 distinct solutions. Now we take the value of A, that is A1, B1, C1, A2, B2, C2, A3, B3, C3, multiply with x, y and z, which is equal to 1, 0, 0. Now if we multiply the left hand side, then we will get A1x plus B1y plus C1z, A2x plus B2y plus C2z, A3x plus B3y plus C3z, which is equal to 1, 0, 0, which implies that we will get A1x plus B1y plus C1z equal to 1. We take that be equation number 1, and a2x plus b2y plus c2z equal to 0. That we take equation number 2. And a3x plus b3y plus c3z equal to 0, and we take that be equation number 3. Now all these three equation number 1, equation number 2, equation number 3 are represent plane. It is given in question the system of equation has two distinct solution when you take order of matrix A equal to 3 cross 3. Now we will see condition of the three plane intersect. Condition number 1, they may meet in a single point. When we draw the diagram, then this is plane number 1. This we take plane number 2. This we take plane number 3. Their intersecting point is this. Condition number 2, they may intersect in a line. When we draw the diagram, then this is plane number 1. This is plane number 2, and this is plane number 3. Intersecting point is a line. Condition number 3, they may form a triangular prism. Draw the diagram. This is plane number 1. This is plane number 2, and this is plane number 3. So there cannot be any matrix of order 3 cross 3 possible to give two distinct solution. Implies that matrix A is not exist. So our answer is equal to 0. Therefore, option number A is our correct option.